Hello everyone, I am Anjali Shukla. Welcome to my channel, PG Cloud Security. Today I'll discuss what is SAST with respect to Docker containers. Let's get started. SAST is Static Analysis Security Testing, and how it is related to the Docker containers, because in this we inspect container images for vulnerabilities, misconfigurations, hard-coded credentials, any dependencies, application code, etc. So we analyze the Docker file and check for latest tag, or if the container is running as a non-root user, then we also scan the base images and look for dependencies and libraries present and scan for vulnerabilities. Third, we check for dependencies, look for the open port as well, like whenever we write a Docker file, what are the expose port present in that? We look for that as well. And then any hard-coded credentials or any sensitive information present in that Docker file. What are the tools that we can use to do the SAST for Docker container? So we have Trivy, Docker Scan, Anchor. If we are doing a SAST, or the static analysis security testing for Docker containers, we are identifying misconfigurations, vulnerabilities in pre-production. So before deploying our application into production environment, we are able to identify those issues, vulnerabilities. We can fix that and deploy only the security tested application in production. We are identifying all those issues in early phases of development lifecycle, and also we are making sure that our images are compliant with respect to the security standards and best practices. Today, I have a demo for Dockle, Hardolint, and Docker Bench for security. We'll see one by one. Let's start with first, which is Dockle. So I will change my directory and go to the Docker lab and install the Dockle. Dockle is successfully installed, and next I will pull the Nginx image. For demo purpose, I am using Nginx image with latest version. I'll pull that image and then run Dockle onto the same image. Okay, it is successfully pulled. Now I will run Dockle followed by the image name. I have these many findings. Let's start with the first one. So it is fatal, and it is saying do not store credentials in the environment variables or files. So probably this Nginx image is having some hard-coded credentials, and I assume this is the GPG's keys, and that is why I'm getting this alert generated. Next, create a user for the container. This container is running as a root user, and that is not recommended. That is why we have this finding, and then avoid using the latest tag. So like this, we have these many findings. Next, we have a Hardolint. I will pull the image. Hardolint is a linting tool for best practices. It scans your Docker file. So image is successfully pulled, and I will create the Docker file. In this Docker file, I am using Nginx as my base image, then running some commands, get update and installing the curl package, and finally running the Nginx. File is created, and next I will run my tool Hardolint onto my Docker file. So in the first half, I am running a Docker container for Hardolint and passing my Docker file to it. I have 4 findings. First is that I should not be using the latest tag. Second, it is saying that if I am installing any package, then I should specify a specific version of that particular package. Third is no install recommend, means I should be using this flag just to avoid downloading any additional packages. If you will notice, I have ID present with respect to each finding. So what if I want to ignore any of the findings here? Let me show you how can we do it. I am reading my Docker file with the cat command and running Hardolint onto it. I'm passing a flag here, -- ignore, followed by its ID, which is DL3008. This finding I have to ignore, so I'm passing its alert ID. And now, if you will notice, I have only these 3 findings. Next, I will do a cleanup, removing the Nginx image and then removing the Dockle. Docker RMI command is used to remove any image. Next, I will remove the Docker file and the image. Next lab we have on Docker Bench security. So this is another good script for security, and it has a common checks for security best practices that we can use when we are deploying our application in a containerized environment. If you will notice, it has 2 prerequisites. Docker should be installed and Git should be installed, because we'll be cloning it, so we'll be needing that. I am already in my Docker lab directory, so I will not change it. I will directly clone Docker bench security GitHub repository. Okay, let me go to the Docker bench security, and here I have these many files present. I will give execute permission to the script. Chmod, when we give read, write, or execute permission to any file, so I'm giving +X means executable permission to my bash script, and next I will run the script. Okay, so it has first section for host configurations. I can see that it is checking our Docker files and directories are configured or not, and specifically for run container d.sock. And then I have second section for general configuration, like if container host is hardened or not. Section 2 is for Docker daemon configurations. If you'll notice, it has checks for each and every section for Docker daemon, for host security, for files and everything. Second is saying that it is checking if a Docker daemon is running, or if it's possible, we should run a Docker daemon as a non-root user. Third section is for Docker daemon configurations files, like what is the ownership of those files, 755, 444, root. And then fourth section is for container images and build file. Fifth is for container runtime. Then we have a Docker security operations and Docker Swarm. So like this, it has 7 sections. And I think total checks it has 86. And it is also taking Docker daemon, Swarm, container runtimes all in considerations. It's a really good tool. Okay, next we will do a cleanup. I will remove all the running and stopped containers. And next I am removing all the images. So that was it in this video where we learned about the SAST with respect to Docker containers. So stay tuned for more videos. Thank you.